Write an algorithm for converting infix to postfix expression using stack. After that, convert the given infix expression into postfix expression using stack, and the expression is given 8 minus 2 plus 3 into 4 divided by 2 raised to 2. Algorithm for converting infix expression I into its corresponding postfix expression P using stack. Now, while we are converting every infix expression, every expression will consist of some white spaces, operands, operator, and parenthesis, open and close parenthesis. So each character by character, we take the elements from the infix expression and convert into its corresponding postfix expression using stack. Step number 1, push left parenthesis onto the stack. So in step number 1, we have to push a left parenthesis onto the stack directly. Step number 2, append right parenthesis at the end of infix expression I. So whatever infix expression is given, at the end of the infix expressions, we have to append a right parenthesis. Step number 3, repeat steps from 4 to 8 by scanning infix expression I character by character from left to right until the stack is non-empty. So we need to repeat the step number 4 to 8 by scanning the infix expressions character by character. One by one character we have to take from the infix expression, and we have to repeat the step number 4 to 8. Step number 4. If current character in I is white space, ignore it. So if we are getting a white space, a blank space, that need to be ignored. Step number 5. If current character in I is operand, write it as the next element of postfix expression P. So whenever we get an operand, so the operand need to be written directly into the postfix expression. The operand need to be written directly into the postfix expression. Step number 6. If current character in I is left parenthesis, push it onto the stack. So if we get a left parenthesis, the left parenthesis need to be pushed into the stack. Step number 7. If current character in I is an operator. So whenever we get an operator while scanning the infix expression, then we need to perform two steps. The first step is pop operators from top of the stack while they have equal or higher precedence than the current operator, and write popped operators as next element of the postfix expression P. That means as long as there are equal or higher precedence operators in the stack than the current operator, then that need to be popped from the stack and should be added as a part of postfix expression P. So we have to repeat this. As long as there are equal or higher precedence operators than the current operator in the stack, operators need to be popped and that need to be added as a part of the postfix expression P. And finally, the current operator need to be pushed into the stack. Push current operator on the stack. Step number 8. If current character in I is right parenthesis. So if we are getting right parenthesis also, we need to do two steps. First one, pop all operators from top of the stack and write it as the next element of postfix expressions P until a left parenthesis occur at top of the stack. So we need to pop all the operators which are available in the stack one after another, and it has to be added as a part of the postfix expressions until we get a left parenthesis in the stack at the top of the stack. And finally, pop and discard the left parenthesis from the stack. So until we get a left parenthesis, we have to take out the operators from the stack and need to be added as a part of the postfix expressions. And finally, the left parenthesis from the stack need to be popped and discarded. This is the end of the loop, step number 4 to 8. And finally, we exit from the algorithm in step number 9. Let us see the example for converting the infix expressions into its corresponding postfix expressions. So first we need to add a right parenthesis at the end of the infix expression. So we have added an additional right parenthesis at the end of the infix expressions. At the end of the infix expressions after 2, we have added one additional right parenthesis. Now we have to scan each character by character from the infix expression. The first character is 8, then after that minus operator, then 2. And we have to perform the set of operations depending on the algorithm. Before starting, at the first step, we have to push left parenthesis on the stack. So a left parenthesis has been pushed into the stack initially. Next, we get a character, first character from the infix expressions 8. Now 8 is an operand. Since it is an operand, it will be directly kept as a part of the postfix expressions. So 8 goes to the part of the postfix expressions. Next character is minus. So whenever we get an operator, we have to look at the stack. Within the stack, if there is any equal or higher precedence operator than minus, it need to be popped. But there are no operators in the stack for the time being, so minus will get pushed into the stack. So we pushed minus operator on the stack. In next, we get 2. 2 is an operand. So this operand will go directly into the postfix expression. Next, we get an operator plus. So when we get an operator plus, we have to look at the stack. Within the stack, if there is any same or higher precedence operator, it need to be popped. So minus has the same precedence as plus. So minus will be popped and that will be kept as a part of the postfix expression. Now there is no further operators available. So plus will be pushed into the stack. Next we get a left parenthesis. Whenever we get a left parenthesis, that need to be directly pushed into the stack. So left parenthesis is pushed into the stack. Next is the operand 3. So it's an operand. So operand will be kept directly as a part of the postfix expression. So 3 goes as a part of the postfix expression. Next we get multiplication. So while we get an operator, we have to check the stack. Is there are any higher or same precedence operator? There is no higher and same precedence operator on the top of the stack. So star will get pushed on the stack. Next is 4. 4 is an operand. So operand will be kept as a part of the postfix expressions directly. Now after 4, the next one is the close right parenthesis. So whenever we get right parenthesis, we have to pop all the elements from the stack one by one till we get a left parenthesis. So here in the stack, we have one operator, which is star multiplication, that need to be popped and has to be kept as a part of the postfix expression. So star will be popped and that will be kept as a part of the postfix expressions. Now there are no further operator that can be popped from the stack because next is a left parenthesis. So left parenthesis has to be popped and that need to be removed from the stack. Next is division operator. So when a division operator comes, we have to look into the stack is there is any higher or same precedence operator than division operator, but there are no higher or equal precedence operator in the stack. So division operator will be pushed on the stack. Next, operand 2. Since it's an operand, operand will be directly kept as a part of the postfix expression. So 2 goes as a part of the postfix expression. Next is the operator, exponent operator. So exponent operator has a higher precedence. So there is no higher or equal precedence operator now in the stack when compared to exponent. Plus and division operator has lesser precedence than exponent. So exponent will directly pushed into the stack. Next come an operand 2. The operand will be kept directly as a part of the postfix expression. Now we get a right parenthesis. When we get a right parenthesis, we have to pop all the operators one by one till we get a left parenthesis. So from top, we pop one element. So that is operator exponent. So operator exponent will be popped and that will be kept as a part of the postfix expression. Then next operator, which is division. Division will be popped and that will be kept as a part of the postfix expression. Next, plus will be popped and that will be kept as a part of the postfix expression. Now there is no further operator in the stack and we reach the left parenthesis. So the left parenthesis need to be popped from the stack and that need to be discarded. So when the left parenthesis, which is only left out element, will be popped, the stack will become empty. So we have to stop the process and we have converted the complete infix expressions into its corresponding postfix expression.